Today we're going to focus on two specific types of sequences. One is a sequence that's created by adding the same number over and over again. The other one is a sequence created by multiplying the same number over and over again. So first let's talk about the adding pattern sequences. This is called an arithmetic sequence. And an arithmetic sequence adds a constant number to each term, which means it adds the same number over and over again to go from term to term. And the number we're adding is called the common difference. And we use the variable d to represent that number. So this right here is the explicit rule for an arithmetic sequence. And you'll see that there are several variables in it. A sub 1 will refer to the first term in the sequence, which will often be given to you because they'll probably list out the first few numbers so that you can identify the pattern. So A sub 1 should be the first term in the sequence. D is the number that they add to go from one term to the next. And the easiest way to find this value is to pick two terms in the sequence right next to each other and subtract the second one from the first one. That way you can figure out what it added to go from the first one to the second one. N is the term number. So we use this if I'm trying to talk about the 10th term in the sequence, then n will be a 10. And this is very easy to confuse with the a sub n value. So if n is 10, that means I'm talking about the 10th number in the pattern. It's the location of the sequence. But that 10th number in the pattern could be anything. It could be 50, it could be 100, it could be a billion. So don't confuse a sub 10, which would be what is the 10th number in the pattern, with n being 10, which is how I specify the 10th number in the sequence. Some of your examples will have you write the recursive rule. And to do this, just use the formula I've given you here. A sub n equals a sub n minus 1 plus d. And this is just saying to find the next term in the sequence, use the previous term in the sequence, but add and then insert whatever the number is for d. That's the only number you need to plug in. For writing the explicit rule is given here, and based on the information you have for your sequence, I'm saying only plug in these two variables, a sub 1 and d. Everything else will be left as is. Don't plug in a number for n, and don't plug in a number for a sub n. We want to leave those as is. So plug in a sub 1 and d, and then do any simplifying you can if you can combine some like terms or compute some numbers in there. So here's a quick example with an arithmetic sequence. The first thing that we need to identify are some of our variables like a sub 1. And in this case, a sub 1 is equal to -7. It's that first term in the sequence that they've given me. The next number you want to identify is d. And as I said in the last slide, the easiest way to find d is pick any number and then subtract the one in front of it. It does not matter which number you pick as long as there's one in front to subtract. So for example, I can pick this number 2, and then I can subtract the previous number, -1, and don't forget double negatives cancel, so 2 plus 1 is 3. And then this is an easy thing to check because I should be saying to add 3 from term to term. -7 plus 3, -4 plus 3, -1 plus 3. And in each case, you can see that it's creating the next number in the pattern. If d is a negative number, then that just means that you're subtracting to go from term to term. But d is always described as what you're adding to go from term 1 to term 2, etc. And you can always find it by picking a term and subtracting the one in front of it. So now I know a sub 1 and d, and that was actually part A. They said, what is the common difference? We just found that by picking a number and subtracting the one in front. It didn't matter where I started, just subtract the number in front. The common difference was 3 in this case. Now they want me to find the 10th term in the pattern. And for this part, I'm going to refer back to our formulas here, and I'm going to plug in the information that I have right now. We want to find the 10th term, so that would be a sub 10. That would be referring to the 10th term of the pattern. It's equal to a sub 1, which we said is -7, plus d, which is 3, times n minus 1. Now we just said we want the 10th term, which means I need to plug in n is 10, because that's what n refers to, the term number. So if I plug in 10 minus 1, that would mean multiply by 9. So now I have a little formula here that I can compute. So coming back to the example, they want to know the 10th term. Well, if I do 9 times 3 is 27, and then if I subtract 7 from that, I get 20. So what I just found is that if I kept filling in more numbers, the next number I know would be 5 and then 8. If I kept going, I'm finding that the 10th number is 20. And yes, with an easy sequence like this, it actually wouldn't have been much work to just sit there and go ahead and list out the next number is 5, the next number is 8, the next number is 11. But sometimes your assignment is going to have you find something like the 100th term. And so you don't want to have to sit there and fill in all 100 numbers by adding over and over and over again. So please practice using the formula with these easy ones, even though you can do it by just listing out the terms, so that when you do get to the harder ones, you already know how to use the formula. Next, they've asked us to find the recursive rule. Well, looking back at the previous slide, I tell you that for the recursive rule, just use this short formula right here. All we need to plug in is D, actually. That's the only thing we need to plug in. So I'm going to write A sub n equals A sub n minus 1 plus, and then I'm going to plug in that D is equal to 3. That is my recursive rule. And this rule is just saying that if I want to find the next number in the sequence, take the previous number and add 3. And it's a pretty easy thing to check, because if I wanted to start from the third term and find the fourth term, then the fourth term, a sub 4, would equal a sub 3 plus 3, and it works. For the explicit rule, we come back to what I have listed up here in the blue box. And I tell you to only plug in two numbers, the a sub 1 value and the d values. And those are the numbers that I found at the beginning of this example. So I'm just going to be plugging in that a sub n equals, now I'm going to plug in that the first term in this sequence was -7, plus, and then we also want to plug in that d is equal to 3, multiplied by n minus 1. So that is one way of writing the explicit rule. We could leave it there. Now, some textbooks would have you also distribute the 3 and write this as 3 times n. And then also 3 times -1 is -3. Because if you do that, we could combine the like terms and instead write this as 3n minus 10. Which I agree is kind of an easier way of writing that explicit rule. So it is a nice way to do it. Some of the questions will be multiple choice on your assignments, in which case you need to recognize that this is the same thing. They just didn't go through that extra couple steps of simplifying it. The second kind of sequence we're going to look at today is a geometric sequence. And these are sequences that are created by a multiplying pattern. So if you are multiplying the exact same number over and over and over again, then it's a geometric sequence. That number cannot change. The number that you are multiplying, if it's a constant number, we use the variable r to represent it. And here is the explicit rule for a geometric sequence. So if you have a couple of the pieces of information, like if you know the first term and you know what r is, then it's very easy to just plug in n is 30 to find the 30th term, to find that 30th term in the sequence. So just like with the arithmetic one, the arithmetic sequence, a sub 1 is the first term, n is the term number. So if I ask you about the 20th term, then plug in n is 20 here. And r is that number you're multiplying by to go from one term to the next. With an arithmetic sequence, I told you to pick a term and subtract the one in front. For a geometric sequence, I'll show you that you can do the same thing, but you're going to pick a term and divide by the one in front. That's an easy way to find r. Divide by the one in front. And then a sub n is the value of that nth term. Again, please don't confuse n with a sub n. If the second term in the pattern is 5, then n is 2, but the second number in the pattern being a 5 means a sub n is 5. So make sure you understand the difference between what the number is and which number in the sequence it is. For writing the recursive rule, you could just use that the next term in the sequence equals the previous term in the sequence times r, because you take the number you have and you multiply by r to find the next one. For the explicit rule, use the equation here in the blue box, but only plug in the a sub 1 and the r values. Leave everything else as is. Don't plug anything in for n. And that way you'll have a rule written in terms of n so that you can simply plug in n is 30, for example, and find the 30th term. So now we'll do an example. So I like to start off by labeling some of the information available to me here. For example, the first term in this sequence, a sub 1, is equal to 5. That will be used at various steps and for various parts of this question. So the first term in the sequence is 5. To find r, pick any number in the sequence and then divide by the one in front. So the only one I don't want to pick is 5 because I don't know a number in front of 5 to use. But I could pick 10, 20, or 40, whichever one you pick. So if I pick 10 and then divide by the number in front of it, reduce this fraction, and then you can calculate what you're multiplying by. Now, in a case like this, it was probably unnecessary. You probably could tell just by looking at it that you are multiplying by 2. But I'm defining this process for you because sometimes you will be multiplying by an ugly fraction, or maybe even a radical, something that's harder to figure out just by looking at it. So the process is to pick a number and divide by the one in front. It doesn't matter which one you pick, since you should be multiplying by the same number all the way across the sequence for it to be a geometric sequence. It shouldn't matter which one you pick, as long as you divide by the one in front and simplify. So we actually just found the common ratio. That's what we just did here. So my part A answer is 2. R equals 2. That's the number we're multiplying by. Now to find the 8th term. Well, for finding a specific term, the best way to do this is to use the explicit rule that I have here. So for the explicit rule, we're going to say that A sub 8 equals, we said that the first term is 5, and that our R value is 2. So I'm plugging in A sub 1 is 5, R is 2, and then since we're finding the 8th term, then that means N is 8, and since I'm subtracting 1, this will be to the 7th power. So this is just a statement that you want to plug into your calculator, follow your order of operations. So 2 raised to the 7th power times 5 gives me an answer of 640. And this is another case where, yes, I actually could have found the 8th term pretty easily by just taking the 4th term, multiplied by 2, multiplied by 2, multiplied by 2, because going to the 8th term honestly wasn't that far out. It wouldn't have been that difficult. It would have only taken a few computations. But again, I'm showing you the formula with some easy ones for the initial practice, so that later on when I say like find the 80th term, you're not going to sit there and spend 10 minutes multiplying over and over and over again. Next, we want to write the recursive rule for the nth term. Well, this one's very similar to what we did with the other kind of sequence. So I'm going to have A sub n is equal to A sub n minus 1 times R. This time it's multiplying by, because that's what our pattern is doing. It's taking the previous term and multiplying by the number R. And I know that R is equal to 2, so I'm just going to plug in 2. So take the current term you have, multiply it by 2, that'll give you the next term in the sequence. Explicit rule, this is what I usually prefer to work with because it's much better for jumping straight to a certain value. So again, I need to use the formula that is listed in the blue box here and only plug in the A sub 1 and the R values. So I'm going to have something with an A sub n, and it's going to equal, plug in A sub 1, we said the first term in the sequence was 5, and then we're multiplying by R. I also want to plug that number in, which was 2. And this is being raised to the n minus 1 power. Now, in this case, there's really not any kind of simplifying you can do here. You do not want to multiply these two numbers together and make it 10, because since 2 has an exponent on it, you can't combine these anymore. So since 2 has an exponent, you cannot multiply together the 5 and the 2. So you would just leave it in this form. And then if I ever went on to say, find the 30th term for me, now we have a nice written explicit rule so that you can plug in n is 30 and then compute this in your calculator to jump to the 30th term. So that's it for the notes on arithmetic and geometric sequences.